Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so guys, this is the fourth lecture of optics in which I'm going to discuss diffraction of light, polarization of light, interference of light is already discussed in earlier class. Okay, so and also I would like to request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so now I will start. So it's diffraction of light. Okay, diffraction of light. Diffraction of light. So diffraction of light means bending of light. Okay, bending of light. Okay, that is bending of light at sharp edges or bending of light at the edges of slits. Okay, I'll explain it. I'll make a diagram for it. Okay, so this is T1, this is slit guys. Okay, and the light is coming here. Okay, okay, this is the light. Okay, and these are the spherical wavefront. These are spherical. Okay guys, this is the you can see the bending of light. Okay, this is bending of light guys. Okay, and this is at center, you can see, and this is this, and suppose this is at angle theta. Okay, this is the screen and this is the interference, so diffraction. Okay, intensity IR, resultant intensity. Okay, so this is the diffraction of light. Diffraction means bending of light guys. Okay, simply in simple language, these are spherical wavefront guys. It is not like it is not looking like it's spherical, right? But consider it spherical. Okay, okay, so this is the bending of light. Okay, and now here I will explain. I'll grab it for you. Okay, so now diffraction of light through a single slit. Okay, we're going to study. Okay, here also types of diffraction will study. Okay, so number one, this is Fresnel diffraction. Fresnel diffraction, Fresnel diffraction. Fractional diffraction means when screen is at finite distance. Okay, so Fresnel diffraction means when screen is at finite distance. Okay, so this means screen at finite distance, finite distance. Okay, and second type of diffraction is Fraunhofer diffraction. Okay, Fraunhofer diffraction, Fraunhofer, and that is Fraunhofer, Fraunhofer diffraction. Fraunhofer diffraction. Okay, Fraunhofer diffraction means when screen at an infinite distance. Okay, screen screen at an screen at an screen at an screen at an infinite diffraction. Okay, screen at an diffraction. Okay, screen at an infinite distance. Okay, so screen at an infinite distance. Okay, when screen at an infinite distance, that causes Fraunhofer diffraction. Okay, okay. Now diffraction of light, diffraction of light, diffraction of a light, diffraction of light through diffraction of light through a single slit, through a single slit. Okay, diffraction of light through a single slit, diffraction of light through a single slit. Okay, diffraction of light through a single slit. This we are going to study. Just let me check whether I'm audible or not, guys, first. Through a single slit. Yeah, I'm audible. Now I'll proceed further. I'll make a diagram first. Okay, then I'll derive it for you. So this is Okay, so these are the light rays, rectilinear light rays. Okay, so from here I will take this as a central point. Okay, this is like this. This angle is theta. Okay, and other rays are like this. These are bending of light. Okay, and the distance between these two rays d. Okay, the distance is d, guys, and this total distance is this slit distance. This is b, guys. Okay, this is b. Okay, and this is the angle theta, and the distance between two rays, this is d, small d. Okay, because these are the and there are these are the wavelets, guys. Okay, and the distance between two wavelets is d, and the number of wavelets are n, guys. Okay, so I'll write it. Number of wavelets, number of wavelets, these are the wavelets. Okay, wave number of wavelets is n. Okay, so there are n wavelets, and the distance between two wavelets is d. Okay, this distance, these are parallel line, guys. Okay, it is not looking parallel, but these are parallel lines, and their distance between these two wavelets is d. Okay, and the distance between the distance between wavelets, the distance between wavelets is d. Okay, I'll try to make straight wavelets, guys. Let me try. Okay, so one is this. Okay, these are the wavelets. And there are n number of wavelets. There are n the number of wavelets are n, and the distance between the wavelet is d. Okay, so I'll show you here like this. This is one wavelet, and this is one wavelet. Okay, and so this is the path difference. Okay, between these two wavelets. Okay, this distance is d, and path difference is, we know, that is d sine theta. Okay, this angle is theta. Okay, so this is this height is going to be d sine theta. Okay, so this is the path difference between two wavelets. Okay, if you talk about three wavelets, then this. Okay, these are three wavelets. Okay, and this is the path difference. So here, this is the path difference. So you can see, this is first wavelet, this is second wavelet, and this is third wavelet. Okay, this distance is d, this is d sine theta, and similarly this distance is going to be 2d, so this distance is going to be 2d sine theta. Okay, so the wavelet is 2d sine theta for this wave and this wave, the path differences. Okay, this this distance. Okay, and b is going to be b is here. You can see this is a distance between this the width of the slit. Okay, that this is b, and because there are n wavelets and the distance between two wavelet is d, then the value of b is going to be, n minus 1 d. Okay, So B is going to be n minus 1, because there are n wavelets and distance between them is d. So this total B is going to be n minus d. Okay, n minus 1d. Simple mathematics. Okay, this is okay. So now we'll find part difference between wavelet first and wavelet second. Okay, and that is going to be d sine theta, right? And the phase difference between 1 and 2, this wavelet and this wavelet, is going to be, these wavelet are here, right? Okay, so these are the wavelets, guys. This is the slit width. Okay, this is slit. These are the uh, light rays. Okay, these wavelets. So we know, right, that part difference is 2 pi by lambda into phase difference, right? Delta 1 2, right? So this is going to be delta, I mean to say phi 1 2 is going to be 2 pi by lambda d sine theta, okay, 2 pi by lambda d sine theta, okay. So 2 pi by lambda d sine theta, okay. Now, so similarly, delta 1 3 is going to be the delta 1 3, this one, the part difference is going to be, this is 2d sine theta, right? Because this distance is d 2d, right? And this is theta, so 2d sine theta. So similarly, the phase difference between first wavelet and third wavelet is going to be, that is 2 pi by lambda 2d sine theta, okay. So similarly, we can get delta 1 and n, okay, part difference between first wavelet and nth wavelet, okay. So there will be wavelets, right? Nth wavelets, and that is going to be, because there are n wavelets, and that is going to be 1 delta 1 n is going to be n minus 1, okay, d sine theta, n minus 1 d sine theta, okay, n minus 1 d sine theta. And similarly, the phase difference between first wavelet and nth wavelet is going to be, that is 2 pi by lambda n minus 1 d sine theta, right? So this is going to be 2 pi, this is going to be n minus 1 phi, n minus 1 phi, phi 1 2, right? Because n minus 1, and this is 2 pi by lambda d sine theta, 2 pi by lambda d sine theta value is this, uh, this one, 2 pi by lambda d sine theta, theta 1 2, right? The phase difference between wave first and second, okay. So we can write like 5, okay. So phi 1n is going to be, phi 1n is going to be n minus 1 phi, okay. Now here we'll let the first wavelet is y1 equal to a sine omega t, okay, and y2 is a sine omega t minus phi 1, okay. There are many waves, so there are n wavelets, right? So so this is the wave equation for first wavelet, and this is the wave equation for second wavelet, okay. Okay, so now similarly we can get the wave equation for third, fourth, so on, right? So this is phi 1 is the phase difference, guys, okay. This is phi 1, okay. So similarly, yn is going to be, for nth wavelet, a sine omega t minus n minus 5. Okay, a sine omega t n minus 5. Right, if I equal to phi 1 2, right, between two wavelets, n minus 1 5. So total wave is going to be y1 plus y2 plus y3, so on. Okay, so from here, because there are n waves which are passing through this slit, guys. Okay, and this is the angle and distance between two wavelets is d. So this, what we are studying, diffraction of light through single slit. Okay, so the light is passing through single slit. Okay, so y equal to this. From here we'll get yr, that resultant yr is going to be, we'll get it, that is sine a sine n phi by 2, a sine n phi by 2 upon sine phi by 2. Okay, and this is going to be sine, this is the yr resultant wave. Okay, this is going to be sine omega t sine omega t minus n minus 1 5, sine omega t minus n minus 1 5. Okay, so now where, or we can write resultant wave, that is yr equal to r sine omega t minus capital T. Okay, we can write where value of r is this one, a sine n phi by 2 upon sine phi by 2. Okay, so value of r is a sine n phi by 2 upon sine phi by 2. Okay, upon sine phi by 2, this one, this value r. Okay, and this theta value is going to be, and theta is n minus 1 theta by 2. Okay, n minus 1 theta by 2, this is theta by 2, guys, theta by 2. Okay, n minus 1 theta by 2. So this is theta is n minus 1 phi, my apology, it's theta equal to n minus 1 phi by 2. Okay, and since we know I is proportional to amplitude square, right, r square, so from here I is going to be equal to k r, k is any constant. Okay, so value of I is going to be k a square, r square value is this, right, this is the r square value, a square sine square n phi by 2. Okay, n phi by 2 upon sine phi by 2. Okay, sine square phi by 2, right, and this is k, and phi is going to be, value of phi is going to be 2 pi by lambda, that we know, right, 2 pi by lambda d sine theta, that is phase difference is 2 pi by lambda into part difference, right, this is d, so 2 pi by lambda d sine theta, right, and this is the, we know, now we can write n phi by 2, we can multiply this by n phi by 2. Similarly 2 pi by lambda we can also divide this, multiply this by n pi by 2. So this is going to be n by 2, my apology, n by 2. This is n by 2 into 2 pi by lambda d sine theta. Okay, 2 will get cancelled, and the value of n pi by 2 is going to be that is pi n or n pi d sine theta upon lambda. Okay, important result you need to note down. Okay, so now let's say n pi by n by 2 phi or n pi by 2 is beta. Okay, let's say it's a beta. So then beta is going to be this one. Beta is going to be pi n d sine theta upon lambda. Okay, pi n d sine theta by lambda. And we know, right, nd is b, because here you can see number of wavelets are n. There are n number of wavelets. Okay, and the distance between two wavelet is the width of distance between two wavelet is d, right, and total n. So b value is nd, right? So simple mathematical calculation. So this is, we can write instead of nd p, right? So this is going to be, beta value is going to be pi n, my apologies, this pi b sine theta upon lambda. Pi b sine theta upon lambda. Okay, so I is going to be, now we'll put the value of I is this, right? In place of n pi by 2, I will put beta. So this is going to be k a square sine square beta upon theta by 2 whole square. Okay, here sine beta, because this is sine n beta n theta by 2, right? N is very large value. Okay, and sine theta by is very small. Okay, so we can put sine theta sine pi by 2 almost equal to pi by 2. Okay, and this is the pi by 2, and from there we can get the value of pi by 2, and that is going to be theta by 2. Okay, theta by 2 whole square. Well, so now this is the one. So I is going to be k square sine square beta upon like in next case. So this is going to be, I is going to be equal to this is k n sine square beta upon beta square. Okay, because here we know that is since we know beta equal to pi by 2, right? So from here pi by 2, this is pi by 2, right? From here pi by 2 value is going to be beta upon n, right? This is guys pi by 2, not theta by 2, pi by 2, right? Because sine pi by 2 equal to almost equal to pi by 2, because the pi is very small, guys. Okay, so and from here this one, right? I'll show you. If beta equal to n pi by 2, we have supposed, right? So from here pi by 2 value is going to be beta upon n. So what we have done, instead of 5 by 2 we have put the value is beta upon n, right? Beta upon n we have put beta, so 5 by 2 whole square is there, right? So this is going to be beta square upon n. N is will go in numerator, so kn upon this, right? This is the one. This is the one, guys. Okay, now you can write this. So from here the I is going to be this I naught, this constant we can say this is I naught, okay, sine square beta upon beta square, okay. So I is going to be the intensity of this total intensity of diffraction is going to be which is passing through this one, right? So the intensity is resultant intensity is going to be I naught sine square beta upon beta square, okay, this one. Now okay, so from here suppose suppose we say this theta is 0, okay. If theta is 0 degree, that implies beta is going to be 0, right? So limit beta tends to 0 sine beta upon beta, this value is going to be 1, okay, if beta is 0. So if limit beta tends to 0 sine beta, this value is going to be 1, or its whole square is also going to be 1, right? So the same thing. So this value will be 1, right? So this means value of I is going to be I naught max, okay. This is the maximum value, I naught max, and that is the central diffraction maxima, guys, okay. Central diffraction, this is central diffraction maxima, this is central diffraction maxima, guys, okay. These are very important formulas you need to note down, okay. This is central diffraction maxima, okay. So now if beta equal to, if this one beta equal to m pi, beta equal to m pi, so it means where m not equal to 0, guys, okay. Beta equal to m pi, that means this one value of I is going to be 0, because sine n pi is going to be 0, sine beta we will put this value, right? Beta equal to m pi, we will put the value, and beta sine m pi, sine square beta m pi is going to be 0, right? The value of pi m is not equal to 0, right? So I is going to be 0, right? Because sine m pi is, m is any integer, right? M pi is going to be 0, right? So that's why the value of I is going to be 0, means minima, okay. That is minima, that is minima, okay. And from here also for first minima, okay, for before that I'll tell you this one, okay. Here since we know, right, here, right, this one, these are important results, guys, you need to note down, okay. These are important results, this one, this one, and this one, okay, this one. So now because here we know, right, this is a beta equal to, value of beta is this one, in place of beta we can write m pi, right? This value is going to be from this. So since we know, we have already studied beta equal to uh, pi b sine theta upon lambda, right? This one, pi b sine theta upon lambda. Now in place of beta, let, because beta is m pi, right? So it is going to be m pi equal to pi b sine theta upon lambda, right? So now pi will get cancelled for m equal to 1, that is first minima, right? First minima, right? For m equal to 1, this value is going to be sine theta is going to be lambda by b. From here we have put m equal to 1, pi will get cancelled, sine theta is going to be lambda upon b, right? So from here value of theta is going to be sine inverse lambda by b. B is the distance, the width of slit, right? And lambda is the wavelength of the light or wave. Okay, so this is the one. Now I'll show you by diagram. This is like this. The single slit, right? Center point, and this is going to be like this and this. Okay, this is theta 1, theta 1. Okay, this is for first maxima. For first minima, right? So this is theta 1, theta. So this is the first minima, theta 1, right? For m equal to 1, theta 1, first minima. So I can write first minima, and this is also first minima, right? For m equal to 1, and this is the central maxima. This is central maxima. Central maxima. Okay. And from here also this one, angular width of central maxima, angular width of central maxima, angular width of central maxima, theta c is 2 theta 1. Okay, this you need to also note down the angular width of central maxima, theta c equal to 2 theta 1, and theta 1 value we know, right? This one. This one is the for first maxima, that is theta 1, right? This is theta 1. So this is going to be, this value is going to be 2 sine inverse lambda by b. So this is the angular width of the central maxima. Okay, theta c, that is 2 theta 1. Okay guys, 2 theta 1. Theta 1 value is this for m equal to 1, this one, right? So this is 2 sine inverse lambda by b. Okay, guys, so this is about diffraction. Okay, now I'm going to solve some questions as well. Okay, so this is about the optics, guys. So what I'm going to do is I'm going to take 3 more lectures after this lecture. In first lecture I'm going to solve the questions of optics which were asked in CSIR net. In second lecture I'm going to solve PYQs which were asked in GATE. In third lecture I'm going to solve PYQs which were asked in Jest, and after that the optics is going to be completed, guys. Okay. Well, guys, so I would like to stop here, and also I would like to request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay. Okay, guys. Thank you so much. Bye now.